Hi viewers, welcome to my channel. So today we are going to learn how to profile your Ruby app using Vernier gem. So Vernier is a new generation profile that has been added that supports any Ruby version which is above 3.2.1 as shown here. So the advantage of this, so when to profile your code, it is that so it can easily point out your mistakes from be it is an IO call or a threads issue or related any GC issue. You can easily profile the profiler will give you the very good information where your code is performing slowly compared on a given circumstances. Okay, so let's see how in action. So just like any other gem, so you just need to add your uh, Vernier gem into your Ruby app. So in this context, I'm showing example in our Rails application. Okay, here. Okay, so Vernier it has been added all together. Okay, so since you are profiling your Rails application, so you have to add this as a middleware in your Rails application in application.rb file. Here I have included here in the Vernier.rb file. So, and if you want to restrict your profiling always, you can effectively you can add your conditions over here. So in this case, with this part, so any API which starts with slash API will only get profiled. So that was means it's all together. So this profiler will run only any APIs with slash with APIs altogether. Okay, and after that you have to add this query parameters just like normal API parameters. Here in this case I have added here. So I have running my simple application which is this a simple Rails controller altogether. So I want to profile this endpoint. So to profile this endpoint using Vernier, you have to add this additional information parameters as well. So where true and what is the interval that needs to be run. So here there is a different information what this profile is. What is that? Vernier interval is the sampling interval that is runs in microseconds, not milliseconds, in microseconds, and uh, allocation interval would be this sampling part as well. So which means tells you your profiler how to profile your code, which means what are the samples has to be taken. All this information it is to be uh, captured in that. Okay. So once you run it all together, so you can profile your endpoint and you just send that. So you will in the response you will get some file as a file response rather than the like textual response rather than some JSON response. And you have to save this information into the file. So if you save this file, so all you will get here it is that there is a one JSON file you will get it. Okay, to view this profiler information, all you have to they have to install. There is a gem called Profile Viewer. So you have to install this Profile Viewer gem, and after that you can run Profile Viewer with this file. So if you run it, so automatically you will get a nice UI. So it will provide you very detailed information about that API endpoint. So here in our case, there is a Puma thread. This is the Puma thread that handle our request. So it will show you the other information where yellow color determines the C Ruby C execution and the red determines the Rails execution and other pink color looks like pink color is going to be the kernel execution and this blue color may be related to the gem execution that was been uh, the distinction that has been added. So this will give you the details of entire the request lifecycle. Okay, so first you start with the marker table. That's how I started using this gem. So marker table is very simpler to understand. In this marker table, so it will give you the entire duration, like from where. So totally it took 0.015 second to execute, and in the execute, the how much the each steps took the duration altogether in the entire your life cycle of the request. So there is 1 microsecond for the GC pause and 108 microseconds for this part, uh, and 881 microseconds for the SQL actor record. All these things. Okay. So this will give you detailing of your entire request life cycle, what has been executed, or whether it is GC process taken more time, or your SQL active record took more time, or your response generation took more time. All these details will be provided over here. Okay. So this is very simpler to understand. Okay. And you can effectively filter here SQL active record. So we can just filter all this information. Okay. And when you click on not over here, it will tell you this on this part. Okay. So in our case here, we have more GC pauses. My though it doesn't execute it, but the GC pause has been happened. So this could be varies for the different execution in your API profiling. But the overall it is this is will give the details of this American API execution. Okay. So marker chart little bit doesn't give you the in details of that, but more of concentrate on the entire execution, and it is concentrated on the how threads has been executed, how uh, GC has been active in your given request lifecycle has been happened. And here, if you see that the thread says running, threads has been stalled, and the threads has been suspended. Thread has stalled means that your thread hasn't been executed. So assuming that if this has more time has been there, which means is that there could be a very good chance that you are running more threads in a given Ruby process, which means is that your thread is waiting more to be executed rather than executing by CPU. So this will tell you that. And this suspended in the sense it is that since we all know GVL lock will be raised when you make an IO call. So here, since it is an SQL active record, which is an IO call in this point of time, so the GVL lock has been released, and remaining times our thread is running. See this, most of the time our thread is running because you are running only one request in only one request. So most of the time our thread is running. So very few milliseconds, might be nanoseconds, the thread has been stalled, and some microseconds this our thread has been suspended. So this will, when you run these things in production, you might get a different colors over here. So but the major thing you have to be here is make sure that your thread hasn't been stalled and thread has been suspended. This will tell you that your thread is waiting more time to be executed rather than executing by the CPU. To prevent that, it could reduce your number of threads within a given Ruby process or Rails process. You will get a, so there would be no thread contention has been happened in a given Rails process. And this is GC marks as well, detailing has been provided. Okay. Here the JavaScript, in the sense it is that you can, this is effectively give you the Ruby frames. When you click on select, when you select all frames, it will give you the Ruby frames and C frames as well, whereas JavaScript select effectively give you the Ruby frames because this is a Firefox a viewer, profile viewer, so they ported to the Ruby. Aaron Patterson did that. So but somehow it is still shows the JavaScript. Okay, whereas native tells you that a C execution. So if you select over here, you will only see the C execution. So all C execution. So if you select here JavaScript, when you see all, so if you see that, you will get a C execution as well. But in the moment now says JavaScript only give you the Ruby execution. Okay. So this is the marker chart table. Now you see the stack chart. Stack chart is stack chart and flame graph will would be diagonally opposite to each other. So where it determines So this will concentrate on how much time that is each piece of code has been spent. Give that. So the more uh, what you call the more peak is there, the more big peak is there. So the more time it is, then in that piece of code, the code has been spent more time here as well. So if you see that, so all these give you the 6.2 milliseconds, 6.2, all those information will be provided here as well. So it just effectively the flame invert to the flame graph as well, but the flame graph doesn't provide you the time here, whereas structure provide the time, how much time it is been taken altogether. So this information, okay, so you can point out that which piece of code actually took more time in a request life cycle. So coming to the flame graphs, so in this example you might see very less details, like the very good detail, but if you have have a very good uh, delay, like a decent delay, you see that information over here, very good details. So in the flame graph, just like the stack chart, if you see this is taking more time. So this is actually, which means is that this will generating my response, could be like generating more my response. That's why my peak is more over here. Okay. So here once you say spin of a thread and the Puma process run and all this in middleware execution has been happened. After that, uh, the Rails instrumentation has been happened, which will be used for our display information. Then my full text class method. See this is the peak that where my code has been picked up controller search and query method has been done. This difference peaks as well. Then after this, my code has been like a JSON has been generated. Okay, that's why this peak is more. So this is the generally when the peak is more, you can just it could be a decent chance that this in this path your code is spending more time. That is one chance. And the second chance is that you could be in that path, there could be more API calls, or the more calls has been there. That could be a chance also. So it's not guaranteed there, but it's a tentatively your that piece of code taking more time to be executed compared to the other peaks that is there in this part. Okay, so coming back to the call tree is effective, that will give you the details of what piece of code has been executed in a given day, how much time it has been samples, how much sample it has been taken in this uh, uh, request life cycle. So you can effectively invert the call stack and get the details as well. So much so 30% samplings samples has been taken. Okay, so compared to this, the I would prefer generally flame graph, and my marker table would be the like marker chart. These are the go-to tools for my profiling when I profile my API, which provide enough details where actually our code is spending more time. And also if you see over here, you can effectively uh, the piece of, you can in a given point of time what has been executed, you can easily filter that piece of code here in the event part. Okay, let's see what has been executed here. Okay, let's see the phase where xscale active record has been executed. Okay, now these are the, at this point of time, the more active records call has been done, and use this is the same flame graph here. See this flame graph, the flame graph would be a little bit more wider, so it doesn't give you the other details as well. So the more there, so more more details has been included in your flame graph. So this will give you entire the details of execution and a given piece of time. Okay, even everything will be filtered out for at a given point of time. So this will you can actually correlate between the different graphs and understand what has been happening between the in a you get a given point of time in your request life cycle. Okay, I hope this video is helpful for you to understand how to profile your Ruby API. So this is the same piece. This needs there is no change in the part, be it is in a Sinatra application or be it is in any uh, Hanami application. Maybe they you can write this all together uh, in the profile.json, and you can profile your code, and you will get the details as well. So as is shown, it is use a Firefox profiler. That is what I was talking about previously. So they create an extension, and using that extension, this is a UI that has been displayed. Hope I think it will be useful, and let me know in the comments if you want any further detailed explanation. I will try to make those videos as well. Okay, thank you. Thank you for your time. See you in next video. Bye.